Here we have a cosine graph. Notice that a cosine graph looks like a series of waves up and down, evenly spaced. The top of the wave, let's start at x equals 0. So right here in the middle, at x equals 0, notice that cosine is at its maximum. That's called an amplitude. At pi over 2, right here, we have the graph is at 0, and at 1 pi, graph is at its negative amplitude. Now let's take a quick look over here at a unit circle. So here's our unit circle. Notice that at 0 degrees or 0 radians, you would have x equals its maximum length. At pi over 2, x would equal 0. It's right at the y-axis. At 1 pi, 180 degrees, you have x equals negative amplitude. It is at its fullest extent to the left. So hopefully you see how the graph of a cosine would relate to the unit circle as you start from 0, maximum amplitude, go to pi over 2, that's 0, x equals 0, y equals 0, and then on around to 1 pi or 180 gives you a negative amplitude. Okay. So that relates to from positive amplitude to 0 to negative amplitude. Next thing we need to look at is the slope of the graph, because right now what we have is a position graph. But what we want to do is look at the slope of the position graph. In calculus, the slope of one graph leads to a second graph, which is called its derivative. So we're going to start right here at x equals 0. Notice at x equals 0, that the slope of the graph, if we were to draw that in, would be a slope of 0. On the other hand, at pi over 2, right there, now the slope is the steepest it's going to be. It's at its maximum steepness. And at 1 pi, we're back to, again, a slope of 0 right at the bottom of that curve. And we could continue this. Now we would have a positive slope and then another slope of 0. Okay. We can continue that backwards on the graph too. If we go negative 1/2 pi, now we're at maximum slope. At negative pi, we're at a slope of 0. At negative 3 pi over 2, we're at maximum slope. And at negative 2 pi, back to the beginning, we're at a slope of negative. So what we need to look at then is how does this slope derive to the next slope? Well, let's use a different color and draw those values of the slope on the same graph. So here at x equals 0, we said the slope was 0, so we're going to draw that as point 0. At pi over 2, right there, we had maximum slope, but it's a negative slope. So we'll use the same amplitude, so that negative slope comes down to here. Again, at pi, the slope of the line at pi is 0, so there's our point. And at 3/2 pi, we're at maximum slope again, this time in the positive direction. So it's going to go there. And so again, we can continue this slope in both directions. Okay, here we are, -1/2 pi is maximum positive slope. -pi is 0. -3/2 pi is maximum 0. And -2 pi is at 0. Okay, well, let's draw this line in then. Connect those points we just wrote. I'm not the best artist, so please don't hold me to that. Now what we have is a negative sine curve. So what that is telling us is then that when we're at maximum amplitude, let's say as a spring is oscillating back and forth, when it reaches the farthest points, its amplitude, the farthest point from the center, the green line is our derivative, that's our velocity. So at the outermost points, the velocity is 0. At the point in the center, when the spring mass passes equilibrium point again, it's moving at its fastest, which then the derivative gives us a slope of, gives us a value at the maximum speed. So you've got your highest value on the derivative curve. Again, when the mass spring reaches its farthest negative amplitude, it stops momentarily. So the green line is our velocity, so it shows us by the slope of the curve that our velocity is 0 at that point. Now, mathematically, let's see, we can show this in a calculus derivation. This is mostly for those of you who are in calculus and those who will be going into calculus next year. If we just do position as x equals amplitude times cosine theta, well, the derivation of this would just be a doesn't change, that's a coefficient. Cosine derives to negative sine of theta. So what you would have is a negative a sine theta. However, that's not all we have to deal with, because we don't have just sine theta. We also have something inside after the cosine. So we have x equals a cosine of omega t. So here's your formula for position. We want to see what the formula for velocity and for acceleration would be. So we start the same way. The derivation starts simply by a stays the same. Cosine becomes negative sine, so we'll put negative sine. But then we have, negative sine of the angle. But then, since that's not just a number, that is actually a formula in and of itself, a function in and of itself, we have to derive the function. So to derive that, we go times. Now omega t, again, t would be a value, a coefficient, so it's not going to go anywhere. It is going to go anywhere. It will be derived away, leaving you with just omega. So that gives us then negative omega a sine omega t. This then is derivation of x, which is the velocity. if we hit sine when sine of omega t is at 0. I'm sorry, when sine of omega t is maximum. The maximum this would be is 1. That means the maximum speed would be is omega a. Notice I said speed, not velocity, because the speed is going to change back and forth in direction, so the velocity is constantly going to change between positive and negative. So that's how we get to velocity. Now let's take a look again. So we left off with v equals negative VA sine of omega t. Okay. If we derive the velocity, then we get the acceleration. Now I could go through this on the graph again for you. It would just take you a little extra time. But essentially, we would take the green line, plot the points from the green line to a new line, just the way we did to get from the blue line to the green line. So the derivative of velocity, or by the way, that is the double derivative of position. Again, for now we leave this part. Those are constants, so they stay where they are. Sine becomes cosine. Omega t remains the same, but then we have to derive the function of omega t, which becomes just omega. I made a mistake. These should not be v's, these should be omega. Correct that in your notes for me, please. All right, so what we end up with then is negative omega squared a, okay, at the point when cosine is at its maximum. This entire thing becomes 1. So omega squared a times 1 is still just omega squared a. So the maximum acceleration would be omega squared a. Again, that negative, that's going to change direction. So sometimes it would be positive, sometimes it would be negative. It would depend on the direction of the position, the direction of the force at that time.